Hello, class. Today we are looking at section 6.3, which is on page 378 through 380. If you look at the first question, number 3, it says use the diagram to complete the statement. If you look at your diagram, notice you have your markings. So we know that the markings mean that certain angles are congruent to each other. So we know angle B is congruent to angle E, angle A is congruent to angle F. So by the AA similarity postulate, it says that if I have two angles that correspond to each other and they're congruent, that means that the third angle is also congruent. So if A is congruent to F, B is congruent to E, then C has to be congruent to D by the AA similarity postulate. So they are similar. So if you look at your answer, triangle ABC is similar to triangle FED. Number 5, they want us to find out what are the missing parts where the question mark is located. So if you think back, we know that the sides have to be proportional to each other. So if we have similar triangles, the sides must be proportion. So looking at that, I know that AC is proportional to FD. BA is proportional to EF. So if you notice, I plugged in. So for AC is 25. FD is 15. BA is Y. EF is 12. So the missing parts is 15 and Y. For number 7, they want us to solve for Y. So to solve for Y, I want to solve the equation. So to solve the equation, I need to cross multiply. So if I cross multiply, I'm going to say 15 times Y, which is 15Y, equals 25 times 12, which equals 300. Divide 15 on both sides. Of course, you know the 15s will cancel out to 1. So Y equals 20. So for number 7, my answer is 20. Going on to the next number, number 9. Number 9 says, in exercises 9 through 14, determine whether the triangles are similar. If they are, write a similarity statement. So I would tell you that the first thing you need to do is that if you can't see the answers, you need to rotate your triangles so they look even more similar to each other. But if you notice, they are kind of reversed. So you have one turned this way and the others turned the other way. So here, if you look at it, we have a right angle indicator. We have 48 degrees and 42 degrees. So what I need to do is I need to check and see if that third angle is 42. So we know that by the triangle sum theorem, that I know that when I add all three angle measures, it equals 180. So 90 plus 48 plus 42 is 180 degrees. When I check this side, 90 plus 42 plus 48 is also 180. So if you notice, all of my angle measures are congruent to each other. So since the angles are preserved, and we know preserved means all the angles are the same measures, 48 is 48, 90 and 90, 42 and 42, so that means they're preserved. The triangles are similar. The similarity statement is, and when you see where a similarity statement is, how do I write this out to show what parts of the triangle is congruent and proportional? So to do that, I know that F goes with K, G goes with L, and H goes with J. So my similarity statement is triangle FGH is similar to triangle KLJ. You need to read postulate 22 on page 375 to get a better understanding of the AA similarity postulate. Going on to number 11. Look at number 11. So again, we're trying to see if these triangles are similar. So if I do my math, I know that I'm trying to find out what the measure angle R and the measure angle V is. So I know by the triangle sum theorem, I know that the measure angle R is 180 minus 85 minus 35, which is 60 degrees. The measure angle V, 180 minus 65 minus 35 is 80 degrees. So you need to look at your angles. Do all three of the angles match? No, they don't match. Angle S and T match, but the other two angles, they don't match. I have 65 here, and the closest that is 60, but they're not equal. I have 85 and 80. They're not equal. So since the angles are not preserved, the triangles are not similar. Remember, you can determine if a triangle is similar by their corresponding angles have to be congruent, and the corresponding sides have to be proportional. Since the corresponding angles are not congruent, then the triangle cannot be similar. Number 12. So this one, it looks a little tricky, but you really have to look at this image. If you need to separate the triangles. I see two triangles. I see a smaller triangle here, and I see a large triangle here. So if you need to separate them into two separate triangles, then you need to redraw the diagram. So it says, if you look at this triangle, by the AA similarity postulate, if angle A is congruent to angle B, and we see that that's obvious, angle C and angle C are also congruent. It's the same angle. If you notice in the large triangle, C is in that triangle. In the small triangle, C is in that triangle. So those two angles, I have two parts that have congruent angles. So since I know that A and B are congruent and C is congruent, that means that angle E is congruent to angle D. So since the angles are preserved, the angles are similar. So you need to write your similarity statement. So I'm going to say triangle CBD is similar to triangle CAE. Number 17. On 17, it says a student uses the proportion 4/6 equal 5 over x to find the value of x in the figure. Explain why this proportion is incorrect and write a correct proportion. So in the answer that they gave us, it says that 5 should be replaced by 9, which is the length of the corresponding side of the larger triangle. And you have a sample answer. So let's explain that. So if you look at this answer, it's saying that if you look at the original statement, I have 4 over 6 and 5 over x. And that's not correct. Because again, you have a small triangle and a large triangle. You have a small triangle and a large triangle. So you have 4 over 6, which is correct. But 4 plus 5 represents the whole side of my big triangle, which should be 9, over the length here, which is x. So that's one way you could have wrote out this statement. Another way you could have written it out is you could have said 4 over 4 plus 5, which is 9, equals 6 over the x. Okay? And if you look at the math, it's going to come out the same. I have 4 times x, 9 times 6, 4 times x, 9 times 6. Still get the same information. So it does not matter how you set that proportion, because you'll still get the same answer for x. So let's go on to our next part. Let's look at number 19. Look at number 19. Okay. On 19, it says in exercise 18-19, make a sketch that can be used to show the statement is false. So the question for 19 says that if the ratios of two pairs of sides of two triangles are proportional, then the triangles are similar. So if you look here, we have to prove that what they're saying, we have to show that this statement is false. Okay? So they're saying that if two sides are proportional, then the triangle's going to be similar. They're trying to do something like the AA similarity postulate, but that doesn't apply for sides. So they gave an example here, and I said 2/4 and 3/6 has a scale have a scale factor of 1/2. But if you look at 4/9, it does not simplify to 1/2. So because my parts are not proportional, okay, make that correction. So since 4/9 does not simplify to 1/2, it doesn't have the same scale factor as the other two sides. So because the corresponding side lengths are not proportional, then they are not similar. So that is proving that this statement here is a false statement. Okay, number 27. So 27 says, in exercises 26 through 29, is it possible for triangle JKL and triangle XYZ to be similar, and explain why not? So it says on 27, triangle JKL is a right triangle and the measure of angle X plus the measure of angle Y is 150 degrees. So the answer here is yes, they can be similar. If the measure of angle X and the measure of angle Y is 90 degrees and 60, it doesn't matter which one is 90 and 60, just label 190 and 160, and the angle and triangle JKL has two angles that are 90 and 60. And by the way, that is a special right triangle, 30, 60, 90. Then they can be similar by a similarity postulate. So again, the similarity postulate says if I have two corresponding angles are congruent, my third angles is also going to be congruent, the same. So if I have a 90, a 60, a 60, these two have to be 30. So since my angles are preserved, is similar. Okay. Last example. Okay, let's look at number 31. So we have an air hockey player returns the putt to his opponent by bouncing the putt off the wall of the table as shown. From physics, the angles that the path of the putt makes with the wall are congruent. What is the distance, d, between the putt and the wall when the opponent returns it? Okay, so if you look at your diagram, and your diagram is also in your textbook, but I just kind of drew it out a little bit so I can see it better. Well, if you look at the diagram here, so we have 20 inches, 26 inches, and then the total distance here is 66 inches. And I know that if I say 66 minus 26, I get 40 inches here. Okay, 26 and 40 will give me 66 again. So if you look at this, this is a similar triangle. And I know that because I have two congruent angles here. These corresponding angles are congruent. These corresponding angles are congruent. So that means the third should be congruent. So I know we're dealing with some similar triangles here. So we can write a proportion. So I have 20 divided by my distance, okay, equals, and then you have to kind of pay attention to how the angles are arranged to see what sides correspond with each other. If you notice that this side is opposite of this angle, and this side is opposite of this angle, so I know to put 20 over D. Okay? I know that the empty side is opposite of this side. The empty angle is opposite of this side, and this empty angle is opposite of this side. So I know to say 26 over 40. Another observation I want you to pay attention to is I started from the small triangle to big triangle. Small triangle, big triangle. And when I go to the right, still small triangle, big triangle. So everything has to be very exact. So be very careful with how you set up your equation. So I'm going to cross multiply. 26D equals 20 times 40. Okay, so 20 times 40 is 800. Divide 26 on both sides of my equation. 26 cancels to 1. 26 divided 26 cancels to 1. 800 divided by 26 equals 30.8 inches, and that's approximately equal to. Okay, so hope these notes were helpful.